Hello everyone, hope you're doing good and welcome back to my channel. Today we are at day 13 of the Geeks for Geeks problem of the day. The question is consecutive ones not allowed. This question has been asked by some of the prominent companies like Flipkart, Morgan Stanley, and many more. So let us see what this question is. So this is the question. Give a minute to read the question and then I will explain you and then we will solve the problem, okay, in an optimized way. So it's given that given a positive number n, okay, n is the input given to us, and yeah, as you can see here, n is the number given to us. And by the way, I will solve this question using Python. So if you are a fan of Python, then please continue with this video, right? So given an integer n, count all possible distinct binary strings. What is binary? Binary means 0 and 1, okay? Count the possible distinct binary strings of length n, which is already given to us length n, such that there are no consecutive ones, okay? Output your answer by modulo 10 power 9 plus 7. What it means, I will tell you this separately, okay? But if you are a beginner, don't focus on all these things now. Just focus on what this question says, okay? It says that we need to count all possible distinct binary strings, okay, of length n. Let us see the input first. Okay, this input may not make much sense to you currently, because initially we should be starting with n equal to 1 to understand what is happening, and then you should be proceeding, okay? So just for the sake of showing you what the examples are, let me show you this. For n equal to 3, the answer is going to be 5. I will come back to this how we are getting it. I will show you the whole tracing of it, but for now just bear with me. And same for n equal to 2 also, okay? So their answer is 3. We'll come to this what happens. So this is the most important part, because see, whenever in an interview you get such a question, you will have to see this first, okay? Based on this, you should basically start, give direction to your thinking on what should be the approach, okay? In this, they are mentioning that the time complexity can be of n, okay? That is good. They're mentioning space complexity will be of n. And let me tell you one, secret of Geeks for Geeks here. In Python, whenever you see this, okay, of n, let me tell you this. If you solve this problem using O of n, your answer won't be accepted basically. Okay, though they have given that the solution can be of O of n space, but I have tried this. They are not accepting the solution of this. I'm going to show even better approach. Okay, the approach which I'm going to show you is of time complexity O of n, but its space complexity is not O of n. Okay, for me it's going to be constant space complexity. Okay, it will be O of 1 basically. So even better approach which I'm going to show you, and these are the constraints for n. N is going to be really big. It will be from 10. Okay, 1 to 10 power 5. Okay, company tax and other things you can see for your own. But for now, let us come to the question. Okay, the question is actually a very very simple question. If you just try to, you just need basically a bit of imagination to understand what is happening. Okay, binary, I have explained what it is, and then you have to go with distinct binary strings. So let us do by trace approach. Okay, so for now, I will just say what is this. Then I will come to the I'm not going to programming approach for now. I'm just explaining how I'm getting the answer. Okay, so when I talk of n equal to 1, okay, let's talk first of n equal to 1. So n equal to 1 means there is only a 0 possible or only a 1 possible, right? Only two. In that, there can never be a consecutive 1, right? There can never be a situation where n equal to 1. Okay. So what will be the answer for n equal to 1? Basically, the answer for n equal to 1 will be 2. Why it is 2? See, when n equal to 1, that means, length of the string is going to be 1, right? So that can be either a 0 or there can be either a 1, right? These are the only two possible approaches here, okay? So what is the answer? Answer is going to be 2. Okay, because you're counting both of them, right? The answer is going to be 2. Now come to the second approach. For n equal to 2, what can be the approaches? Okay. See, there is a trick here now. See, I am not going to derive the answer for n equal to 2 directly. I will use the answer for n equal to 1 and then I will do it. Okay. So what I will do is uh, see, in this case, it is ending with 0, right? For 0, I can add a 1. Okay. See, for anything which is ending with 0, I can add a 1 after it. No problem. Okay. It will be a part of the solution. Okay. I can add a 1 also after this. I can add a 0 also after this. Please try to understand what I'm doing. See, I am taking this 0. If you follow this approach, you will understand how it will work for the rest of the cases. Okay. I am taking this 0 as it is. Okay. What and all I can add after that, I can add a 1 after that, or I can add a 0 again after that. Okay. So initially I had 0, I add a 1 here, and I add a 0 again here. Okay. Now come to this one. Okay. What and all can be added after this one? After this one, I can add only a 0. I cannot add a second one because there should not be consecutive ones. Okay. So what should be the answer for n equal to 2 now? The answer for n equal to 2 should be 3. Okay. Answer equal to 3. Now come to n equal to 3. Okay. So for n equal to, what I am going to do? See, again same thing. I will take all of them and I will try to see what all can be manufactured in that. So the idea here is I'm not going to recalculate everything for n equal to 3. I'm going to use the solution already calculated for n equal to 2 to get the answer for this. Okay. So See, if you take this 0 and 1, it is ending with 1, right? So see, I'm first of all writing 0 and 1. What I will going to do, see, I can add only a 0 after that. Okay, I cannot add 1 because it's already ending with 1. I cannot add another 1 after this. Okay, so I can add only a 0 here. Okay, I will add 0 and that's it. Okay, now come to this. It's ending with 0, right? So I can add a 1 also and I can add a 0 also after that. Okay, so two things I'm going to add. Okay, what are the two things? See, I'm writing 0 0 first and I'm writing 0 0 again. Okay, so what all I can add after this? After this 0 0, I will add a 1. After this 0 0, I will add a 0. Okay, idea here is whenever thing ends with 0, I can add a 1 to it and I can add a 0 to it. If a thing is ending with 1, then only option for me is to add a 0. Okay, so these are the two things. Now again, this thing it's ending with 0. Okay, I will just copy it and I will paste two times here because there are two possibilities for this. Okay, I will add a 1 after this. Okay, and I will add a 0 after this. So what are the answers we are getting? We are getting 1 2 3 4 5 5 answers. Okay, in this case answer is going to be 5. So till now, I've shown you some. Okay, if you want to trace now, see, this is what is being explained here. Okay, how we see if you try to match whatever I've highlighted now, okay, with this whatever we are getting, you will see they are same, right? You will see they are same. So answer is 5. And for n equal to 2, I think they have given answer is 3. And again, we are getting the same. Okay, so these are the various things they have given, and we are also getting the same. Okay, so now I've shown you while tracing it. Okay, but we'll have to solve it programmatically. Okay, so for this, what I'm using is I'm going to use a basically a map. Okay, what is a map? Basically map means it will map a key with a value. Okay, so I am going to see what I mean by 0. 0 means all the strings which end with letter 0. Okay, and all the strings which end with letter 1. Okay, so what are the values going to be? These are going to be the number of strings which end with a letter, sorry, which end with 0, and number of strings which end with 1. Okay, this is going to be a number of that. Okay, so initially it's going to be like this. Okay, 1 and 1. This is for the case 1. Okay, so because for n equal to 1, I have hard coded the value here. Okay, so for n equal to 1, I'm just simply hard coding the value as 2 because we have only two approaches. Okay, either it can be a 0 or it can be 1, right? So I've hard coded it. The answer is for whenever this n equal to 1, you can return 2. And by the way, they're clearly mentioned n cannot be, and because n can be only 1 or greater than 1. Okay, so basically this case is not needed. Okay, I will just remove it. But you should always check this. Okay, you should not simply assume that f0 will not be included because uh, I thought that 0 will also be edge case, that's why I included it, but I will just remove it now. Okay, now let's come to the tracing part. See, initially, see, my answer for n equal to 1 is done. For the rest of the answer will be for anything n greater than, for n greater than 2 and above. Okay, that's what we are doing. So initially a is like that. Okay, now for a equal to 2, what should we do? See, as I mentioned, this basically means all strings that end with 0, and this is the number of such strings. Okay, this is the number of such strings. This key of 1 means all the strings which are ending with 1, and this number means its value means the number of such strings will end with 1. Okay, please pause my video, rewind my video, and please try to follow everything. Okay, I've tried to give you a very detailed approach. Okay, this might be a slightly like, see, this kind of data structure, I guess if you're a beginner you may not be knowing this, but please try to understand this. This will solve a lot of your problems. Okay, so now coming to B. Okay, now for coming to n equal to 2, what should we do? See, very simple. First of all, I'm talking about string with ending with 0 for the n equal to 2 case. Okay, I'm talking about n equal to 2 case. That means the string can be of length 2. Okay, for that, how many strings are going to end with 0? That number I have to fill here. Okay, this thing I have to replace with a number. Okay, so what I will do is go to n equal to 1. See, ending with 0 means I can take, see, when 0 can be added. Okay, if the number is already ending with 0, I can add a 0 to it. If the number is going to end with 1, and again I can add a 0 to it. Okay, so take both of these numbers. Okay, this one and this one, add it and write it here. Okay, so this will be 1 plus 1 2. Okay, this will be 1 plus 2. Now when I can add a 1, I can add a 1 only if the string is ending with 0. Okay, I can add the 1 only if the string is ending with 0. Okay, that is the case here. Okay, so this is the representing the number of strings with end with 0, so I can write it as it is here. Okay, okay, now I will add both the values. Okay, this is a sorry, this is a value, this is another value. So what is my answer? 2 plus 1 equal to 3. Okay, so for n equal to 2, the answer is going to be 2 plus 1 equals to 3. Okay, now come to the case of n equal to 3. Okay, again these things I have to fill. So I will go to the, see, for n equal to 3, I will go to the previous case. Okay, I have to find for n equal to 3 which how many strings are going to end with 0. When I can add a 0 for both. If the string is already ending with 1, I can add a 0. If the string is already ending with 0, I can add a 0 again. Okay, so I will take this number and this number. Okay, and I will write it here. So 2 plus 1 equals 3. Okay, I will simply write 3 here. Okay, done. Now, when a string can be ending, so for n equal to 3, when we can add a string with 1, okay, when we can add a string with 1, okay, in this case, we can add a 1 to the end of the string only if it is having a 0. So this is the case, okay. So these are the number of strings for n equal to 2 when a string can have 0. To this, I will add a 1, okay. So it will be 2 here directly, okay. Now we will add both these values, okay, 3 and 2. I will add 3 and 2, and the answer is going to be 5, okay. So this will be 3 plus 2 equals to 5, okay. Same is the case here, okay, for n equal to 4. See, this means the number of strings of length 4 which will end with 0, okay. So how to find that? Take any string of length 3 that is ending with 0, or take any string of length 3 that is ending with 1, and just we can see, take any string with is ending with 0, you can add a 0 to it. Take any string of length 3 that is ending with 1, you can add a 0 to it. So basically we'll add these two numbers to get string of length 4 that is ending with 0, okay. That will be 5, okay. That will be 5. Similarly, first for a string of length 4 ending with 1, okay, ending with 1, what are the cases? To get this number, we'll go back to one step, that is for n equal to 3, which are the strings ending with 0. Only for those strings I can add a 1, right? So this is the number of strings that ending with 0 for n equal to 3. Only to these strings, okay, only to these strings I can add a 1. So the answer will be 3 here, okay, 3. So what will be the answer here? It will be answer is equal to 5 plus 3 equals to 8. Okay, this will be the answer, okay. So this is the 5, this is the 3, okay. So please rewind my video. I know if you are doing this for the first time, if you're a beginner, this things will be hard for you. So see, I'm to, as I mentioned in initial itself, this is the advanced approach, okay. If you go with the O of n approach, you may be able to solve it, but I don't think your answer will be accepted, okay. So that's why I'm doing an advanced approach. In this case, in my solution, it is going to be O of 1, okay. Time complexity will be O of n only for my solution also, but in my solution, this will be O of 1, okay. So yeah, coming to the coding part of my solution, what I'm doing is, see, this is the edge case. Okay, I'm simply giving the answer. Okay, n equal to 2. Sorry, the answer is 2, right? I'm returning it. This code will be followed only if my n is greater than 1. Okay, so what I'm doing, first of all, I'm defining the mod here. Okay, why mod? See, mod. Why this concept of mod comes is, see, whenever, see, as you might be knowing, like an integer may have some bits, so there is a maximum number which we can store in that bit, okay. To ensure that our answer does not exceed the bits assigned for this question, the computer is the space assigned by Geeks for Geeks is designed in such a way that the answer will never be exceeding certain number of spaces, okay. To ensure that they are giving this condition, okay, always divide your answer by 10 to the power 9 plus 7. To ensure that I'm doing this, okay, mod is equal to 10 power 9 plus 7. In Python, if you have to do 10 power 9, you have to give double stars, okay. 7 plus 10 double stars 9, okay. 10 power 9 plus 7, okay. And this is a key, as I mentioned. The key way, see, key, this is a map basically. It has two things, one key and one value, right? The key refers to a string of length 1 ending with 0. Similarly, this key refers to a string of length 1 ending with 1, okay. And these are the numbers for those things, okay. Any string that is ending with 0, what is the number for that? Any string that is ending with 1, what is the number for that, okay. This loop I am going to see why I need to run it like this from 2 to n, okay. See, in Python, I'm assuming that you are very new to Python, that's why I'm giving every detail of it. See, this is a 2, right? That means this loop, the I value will be starting from I equal to 2, okay. And this is n plus 1, okay. That means the last value for which this loop will run is I is equal to n, okay. One less than the number I have highlighted, that is I equal to n, okay. Every For every law, I'm redefining a b, okay. Whatever is the past b, you can forget that. I'm redefining the b, a new v, okay. A new will be allotted to this v, right? What I'm doing for b, that is for any string of b that is ending with 0, how to find it? I'll go to the previous step, okay. What is the previous step? The a is the previous step. You can just remember, a is the past steps valuation, and b is the new steps valuation, okay. So how to calculate for b equal to 0 and for b equal, sorry, for b of 0 and b of 1? As I mentioned, a of 0 and a of 1, you can add them, you will get b of 0. Similarly, simply take a of 0, you will get b of 1, okay. That means, see, for any string in a ending with 0, you can add a 1 to it, okay. Similarly, for any string in a that is ending with 0, or for any string in a that is ending with 1, for both of them you can add a 0 behind it, okay. That's not violating the value. This is what they mentioned, right? See, 1 should not be consecutive, zeros can be consecutive, right? You cannot add 1 after another 1, okay. But for anything that is ending with 1, you can add a 0. Similarly, for anything that ending with 0, you can add a 1. Sorry, anything ending with 0, you can add another 0, okay. This is what it is. And see, there is some complex part here also. See, anything divided by mod plus anything divided by mod and whole divided by mod will give you, these are consistent. These are like division rules actually, modulus rules. You can go through that, but you can even remove it for better understanding. You can remove this part, and the answer will still remain the same. But the approach which I'm trying to say is that if you do this modulus, they're consistent with the results. Okay, remember the ultimate answer you have to return modulo this. Okay, modulo the mod value. So either you can do it finally, or you can do it even in the intermittent steps. Okay, this will be even more efficient. Okay, that's what I'm going to, I will suggest doing it. Okay, see why I'm using this modulo. See the places in which I've written the modulo. If you want to really understand it, just Google it. You will get the rule here. Okay, a modulo, see a modulo something, let us say 10 plus b modulo 10 and whole divided modulo 10 is a consistent result. Okay, instead of doing it at the last, I'm doing it at every step. That's what I would just want to say. Okay, this thing. Okay, then finally, as I mentioned, b is always the latest one. A is the one step older than that. Okay, so in for going before going the next loop, what I'm doing is I'm assigning a to b. Okay, so whatever b is having now, that will now be even a will now point to it. Okay, even a will now point to it, and in the next loop b will be redefined. Okay, b will be redefined, but the previous value of b is now with a. Okay, this is what is being happening here. So when this loop ends, a and b will be pointing to the same thing. Okay, a and b will be pointing to the same thing. When I'm coming back, as I mentioned, see, if you have seen my tracing, what I'm doing is at any step, what I'm doing, I'm simply adding the values. Okay, 5 plus 3, and at that I'm returning as the answer. That's what I'm doing here. Simply take a of values, take a sum of it. Okay, take a sum of it, and simply divide it by modulo and return it. Okay, I will show you how it works. See, it's getting accepted. Remember one thing, this is very easy to do with off an approach. Okay, but that is not an optimal approach in this case. What I'm doing is, see, I'm only using two variables, a single a is a map and b is a map. Okay, only two maps I'm using. Okay, so in my case it will be o of 1 here, and it will be o of n only for me also. Okay, so this is even a better approach than what geeks were expecting from me. But remember, in Python, because Python is comparatively to Java and C++, it is using slightly more memories. That's why I will advise you, whenever you see o of n, if possible, think of an approach that is o of 1. Okay, that is o of constant. That's what I'm trying to say. I'll just run and show you, and it works. I will give the solution in the description of the video also. You can go through it, and as you can see, this is getting accepted. Okay. So, yeah, friends, that was all for today. Hope you have enjoyed the video. Thanks a lot.